So a very good evening to all of you. Okay. Okay. So a very good evening to all of you. My name is Mohit teacher, and I'm okay. So finally it's done. Let's start. So a very good evening to all of you. My name is Mohit teacher, and I welcome you all on the YouTube channel of TEQIP classes. So this is all about me, and we were started about the unconventional machining or the non-conventional machining part. Good evening, Somranjan. We started this non-conventional machining part, and we have discussed two of the machining processes, that is chemical and the ECM, electrochemical machining operation. So in the last video or last lecture we started yesterday the electric discharge machining. Okay, so what we have discussed in the yesterday, that is about the idiom, that is the literature part, the principle and the working part. Okay, so what is that working and what is the principle part, that I will just brief you today. Along with that, we will cover the material removal mechanism. Okay, so today we are, first of all we will see that one, then we'll go for the dielectric medium fluid, means what are the properties that is required for the dielectric fluid, as well as we'll see the electrode materials, that what materials or what characteristic it should require when we are taking the electrode materials. And we also study about the 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 power devices that we are using. Okay, so power generators especially. Okay, so that analysis part we will cover by today itself. Okay, so that if it will cover by today, then we can start the numerical problems from tomorrow onwards. Okay, so let's start. So, okay, so material removal mechanism. So, as I said, as we discussed in the yesterday class, that principal part especially, that this is the tool and this is the workpiece. Okay, both are connected with the DC power supply. Okay, both are connected with the DC power supply. In between that, we are filling the dielectric medium. Okay, in the container we are fixing and we are filling the dielectric fluid. Okay, now this gap generally it is जो दिख रहा है इतना होता नहीं है, which is very minute. Okay, now we are connecting this tool, this is the tool and this is the workpiece. So this we are making this tool connecting with the negative side, means cathode, and this we are connecting with the positive side, that is anode. So what will happen, that once the potential difference is created and when it reaches to the steady state condition, immediately the positive ions start releasing from this workpiece surface. Okay, and negative ions, means electrons, start releasing from the cathode side. Okay, now is the gap is very minute, and the dielectric fluid is also there. So dielectric fluid contains the molecules. Okay, dielectric molecules. So is they are not like electrons and positive ions, they are like they move here and there. Okay, so they are not very distant, so they move here and there. So what will happen, they will collide with the ions as well as they collide with itself. So they will, that will increase the velocity, and because of that the resistance between the gap is increases. Because of that the spark is generated. Okay, and that is only the reason that of the removal of the material. Okay, and now as we have already discussed in the literature part, that whatever this spark is generated, that is very uniform and predictable, that in which direction we have to flow. Now direction how we will define, yesterday also I said that जो आपकी irregularities हैं, ठीक है, ये जो surface पे irregularities आपकी बनी हुए हैं, ठीक है, this first of all it will try to find out that where is the minimum gap. Okay, जहां पे आपका मिनिमम गैप होगा वहीं पे सबसे पहले स्पार्क जनरेट होगा. तो अगर मान लीजिए जो ब्लैक शेप्स अभी मैंने बनाई है, तो मान लीजिए टूल की साइड ये वाला कनेक्शन है एंड वर्कपीस की साइड ये वाला पोर्शन है. सो फर्स्ट ऑफ ऑल द स्पार्क विल बी जनरेटेड इन दिस एरिया. Okay. Next, once the spark is generated, the material is deformed, so this portion is completed. Now, as we are connecting this servo mechanism with the tool, so we are feeding this tool toward downside toward the workpiece. So as we are feeding downward side, so whatever next surface irregularities or the minimum gap there, this spark will reach to there. Okay, it's not like spark is generated over here and we are moving toward this side. It is not like that. Okay, arc nahi generate ho rahi hai, it's the spark. Okay, so when you will reach to the next one, if this is the minimum gap, this is the minimum gap, the next spark will be generated over here. So this will basically, this irregularities will define the which direction we have to flow. मान लीजिए कि generally we have to keep very clean surface, but if we have to make very small size area, means we have to remove the material from a small size area, then we usually making some roughness over there, okay, on the tool side, so that accordingly the work surface, the shape is formed over the workpiece surface. Fine. नाउ ये तो हमने कल भी डिस्कस किया था, एंड इसके बाद जो कुछ डिस्कस किया था वो ये भी था कि लाइक is this spark is generated, okay, and these electrons are moving, and here and then they are generating the spark. Is they are moving here and there, they are because they are reaching a very high velocity. So if velocity is there, it means no doubt that they are if the velocity is there, then no doubt the kinetic energy of these is also very high, because what is kinetic energy? That is half mv square. Okay, so velocity is high, then no doubt the kinetic energy will also be high. Okay, so kinetic energy high here, so they are randomly moving here and there, and because of this, as the gap size is also not that much large, so this positive ion will strike over the surface of the tool, and this negative ions means electrons will strike over the surface of the workpiece. Strike भी कह सकते हैं या फिर impingement भी कह सकते हैं, ठीक है. So these impinge over the surface, positive ions over the tool and the negative ions over the workpiece surface. Okay, so they will impinge, and they will because they have a very high kinetic energy. So when they will impinge, this immediately this high kinetic energy is converted to the thermal energy. Okay, now as this thermal energy is generated, means this collide with here. Okay, so this will generate the thermal energy, and this thermal energy means the temperature which is immediately rise at that surfaces is in the range of 10,000 degrees centigrade. ठीक है, this is 10,000 degree centigrade. तो इनिशियली मतलब अगर आपका इमीडिएटली अगर 10,000 डिग्री सेंटीग्रेड राइज हो जाता है या फिर उस रेंज में रहता है, तो मटेरियल इसमें क्या होता है कि मेल्ट नहीं होता है. अगर हम स्टील की भी बात करते हैं नॉर्मली, तो वो 1535 आयरन जो मेल्टिंग पॉइंट है, दैट इज 1535, तो ये उसका जस्ट 7 to 8 टाइम्स है. ठीक है, और अगर मान लीजिएगा आप टूल या फिर वर्कपीस, क्योंकि वर्कपीस जो बना रहे हो हियर, नाउ these workpiece are generally treated as a tool in the conventional machining. So no doubt we are using a very high strength material of the workpiece. So 10,000 है तो manageable है, ठीक है, इतना कोई ज्यादा नहीं हो रहा है. ठीक है, so because these obviously this workpiece has a good wear resistance properties and all these things, so that can be wear. Okay, now because of that the high temperature is generated, and this because of this high temperature the material from the workpiece not only melt but it evaporates. Okay, so okay, fine. So what is happening, the material is removed. Okay, the material is removed from the cathode side as well as from the workpiece area, so that will basically segment in between the gap. Okay, or wherever the material is deformed from the workpiece, that will sediment over there. This is as we are continuously supplying the current. Okay, so what will happen here, the ionized plasma is formed. Okay, ionized column is formed. Yesterday also we talked about that. That is ionized column is formed. Okay, and this ionized column, why this ionized column is formed? Because we are continuously supplying the current. Like we do not want the arc, we want the spark. Okay, we do not want the arc, we want the spark. So what will happen, So we want the spark. So for this spark what we have to do, like lighter कैसे करते हैं, lighter में spark जलाते हैं. So first we are pressing it, then immediately the spark is gone, again we are releasing it, and again there we are applying the, then we are pushing it. So it means that what we have to do, if we are continuously supplying the current, then that will not make this spark, that will form the arc. So what we have to do, we have to switch off the power supply immediately. Means once the spark is generated, immediately we have to turn off the power supply, and what will happen, this current will be shut down, means current off ho jayega. So what will happen, that whatever the ionized column is formed, immediately that disperse, and that is like collapse. Okay, this ionized column, immediately as you turn off the current or the power supply, this ionized column is collapsed. Because of this collapse, because of the collapsing of this ionized column, there is a pressure, pressure or shock wave is generated. Shock wave is generated. Okay, now what will happen because of that, means suddenly as the this ionized column is collapsed, suddenly this pressure and shock wave is generated. Now this pressure and shock wave, as it is generated in between the gap where the dielectric fluid is also there. So this dielectric fluid along will try to escape that surface or escape that area where this shock wave is generated, because obviously it is generated in between the gap only. So whatever the amount material or the fluid is there, they will try to move from that area. So when they will try to move from that area, definitely they will move outside and sediment over the bottom part of the container that we are using. And after that we discussed in the working part that we have some exit hoses. So through that we are keeping that outside. Okay, there's material and the dielectric fluid, and there is a reservoir in which we are filtering, and we have seen that. Okay, so this is how the material removal takes place. Okay, means how the material is removed, how the deformation is takes place, and how the material became coming out from the this region. Okay, now जो points है वो पढ़ लेते हैं एक बार. High speed electrons and ion impinge on the workpiece and the tool respectively in an ionized cylinder. Okay, we have discussed kinetic energy of these electron and the ion while impacting the surface of the workpiece tool respectively converted into thermal energy, and that rises the 10,000 degree centigrade. Okay, the rise in temperature causes removal of the material from both the area. Okay, the material removal occurs due to instant vaporization of the material. Okay, next is, as the potential difference is withdrawn, the ionized column is no longer sustained. The collapse of ionized column generates pressure and the shock wave that we have seen, which evacuates the molten material. Okay, means evacuates means immediately it whatever the molten material means, because we are calling it molten because this is deformed. Okay, so this molten material is evacuated from that area. Okay, forming a crater of the removing material around the site of the spark. So what is happening here, that is if you will see the workpiece over here, if you will see this zone, if you will see this area. Okay, so what will happen there, if this is the this is the workpiece. Okay, so when the spark is generated, okay, so whatever the because this spark is come first, immediately it will come in contact with the workpiece surface. At which surface, at which area where the gap is very small. So now we are assuming that it's a flatten, then there is a very smooth. So randomly मान लीजिए कि आपका tool जो है उसकी regularities यहाँ पे है. So this area is coming in contact. So from the material is removed from this area. Now material is removed. So how the material is removed? अब material remove means आपका material remove हो कैसे रहा है? Cracks initiate कर रहा है. क्रैक्स को इमीडिएटली क्रैक्स को इनिशिएट करके जो भी एरिया है जिसमें भी स्पार्क का इफेक्ट है, वहां से मटेरियल रिमूव हो रहा है. तो देखिए अब इसमें क्या है ना, जब हम मटेरियल रिमूवल रेट को जब कैलकुलेट करते हैं तो उसमें बहुत सारी शेप्स को हम कंसीडर कर सकते हैं. बट अगर आप डिफरेंट टाइप्स ऑफ द शेप कंसीडर करेंगे तो हम क्योंकि ना ही हमारे पास स्पेसिफिक एरिया है कि जो कोई हमने एज्यूम नहीं किया है कि आपका स्क्वायर क्रॉस सेक्शन बन रहा है, कि आपका सर्कुलर क्रॉस सेक्शन बन रहा है, कि आपका रेक्टेंगुलर बन रहा है या कुछ और बन रहा है। ओके, इनसाइड आल्सो मतलब इनसाइड द वर्क पीस मतलब डेप्थ साइड भी हमें क्या एरिया बन रहा है, कितना लेंथ तक जाएगा वो हमें पता नहीं है। सो we are just assuming that whatever the surface means just जो भी amounts of the area that is released from here means because of this spark, this will be treated as a semisphere. This will be treated as a semisphere. Okay, now what is meaning that कि जहां पे भी आपका यहाँ पे स्पार्क यहाँ पे जनरेट हो रहा है, ठीक है, जहां पे यहाँ पे आपका स्पार्क जनरेट हो रहा है, जो रेडियस यहाँ पे है, this radius is throughout, if we are assuming that this radius is small r, the small r is radius is throughout this on this workpiece. Okay, so because of that only we can say that if the spark is there, then the whatever the area means length over here in this side effect up to what length, same effect will be in this side as well. Fine, so same effect will be on the bottom side of the workpiece as well. So we are assuming that this is the semisphere, so the small r is the radius of that. Fine, is it clear to you now? Okay, so now what is happening that when you will see from the top view, okay, top view, if you will see this cross section, then this is your workpiece, okay, and if you will see this one, then it should be like looks like this one. It should be looks like this, okay. So this is nothing but we call it as a crater. ठीक है, जब मैंने आपको कल when we were discussing about the literature survey part, first definition means first sentence was in the 1976 1766 one of the chemists by profession or automotive engineer Joseph Priestley was discovered the erosion of the craters. Okay, means they discovered the electric discharge at the cathode surface due to the erosion of the craters. Now erosion was clear yesterday, that is the meaning of wear only, means wear was happen in the form of craters. Okay, now what is this crater? Now it's clear to you now. Fine, so this crater, molten material forming a crater of removing material around the site of the spark. Now it's clear to you. The generator is used to apply voltage pulses between the tool and the workpiece. Now yesterday I also mentioned one of the things like this one, that controlled plus pulse generator is used with the DC power supply. Now I can tell you, because we have discussed this part, that as we are continuously supplying the current, so once the ionized plasma is ionized column is formed, if we continue supply this current, then it will form it, this spark is converted into the arc. So we have to remove the material, means the pulse means first for the time being it's on, then again it is off, then again it is on, then again it is off, like that. Okay, so please keep in mind that one. Okay, so that's why we are using this generator is used to apply the voltage pulses. Please, is it clear to you now? Pulses between the tool and the workpiece. A constant voltage is not applied. We are not applying a constant voltage. Only sparking is desired in EDM process. We discussed it yesterday itself in the literature part, that two of the Russian scientists they got an assignment, and finally during the experiment they at the end they come up with the idea that spark is more uniform and predictable in the oil than in the air. So here throughout this EDM process we will talk about the spark only. Fine, so sparking is desired in EDM process rather than the arcing. Arcing leads to the localized material removal at a particular point, whereas spark gets distributed all over the tool surface, leading to uniformly distributed material removal under the tool. Okay, इसका मतलब थोड़ा सा ये भी है कि जो आपका spark generate हो रहा है, that will basically not only remove the material from the workpiece area, that will remove the material from the tool as well. Okay, so now इसका मतलब ये है कि like you can say that sir, how it can be possible that tool itself is deforming, but the percentage ratio of the tool and the workpiece is very small. Okay, so no need to worry for that. Okay, so this is just like actually it is not the voltage and current profile is not like actually this one, but you can just assume that initially initially from here there is no voltage supply. Immediately as the voltage is on, immediately the voltage rises, and once you will turn off it, immediately this voltage जो है that will become zero, and again it will be off for some time, and again it will become zero. When means in this region from here to here, this is one cycle will complete. Okay, so if this is in this time the charging is on, or the we are supplying the current, so this is the time in which we are supplying the current, okay, or we are supplying the voltage, okay, in which the spark is generated also, we can say. In this time there is no spark is generated because there is no supply of the voltage and the current, so this is the time of during which the spark is off. Okay, so this is the total timing, means this is the cycle time, we can say over here. This is TC, so this is TC is the cycle time. Okay, now it's clear to you. Similarly, now if you will see the current, initially there is no current when there is no power supply. As the voltage is initiated, current takes some time, because current depends on the what length we are using. Okay, means what length of the spark or what the gap of the spark is there, so that depends on that. So that has some linear relationship, always it has some linear relationship only. You have seen this linear relationship in the welding terminology, welding. Okay, so this is the linearly varying. Okay, is it will okay, when the voltage become maximum, this will also become maximum. Okay, but voltage become maximum immediately, but it takes some time. Okay, now is the voltage turn off, means जैसे ही आप down करते हैं voltage को, so again it will take some, as it has some linear relationship, so it will take the same time, मतलब यहाँ से लेके यहाँ तक जितना टाइम था आपका, ठीक है, so this will time will be the same. Okay, मतलब जो पीरियड है वो सेम रहेगा, जो टाइम पीरियड है वो सेम रहेगा, वो चेंज नहीं होगा, इंटरवल चेंज हो सकता है. ठीक है, so it's clear. Now let's move to the just I am briefing you about this dielectric fluid and the electrode material, then we'll move to the analysis part. So dielectric fluid, what are the characteristics is required for the dielectric fluid, and why we are using the dielectric fluid? Because is you all are aware about that in welding. Basically, we are using the if we are talk about the shaded metal arc welding, in which the consumable electrodes are used. So in consumable electrode, if you will see bare wire, means if you will see the electrode, then inside there is a bare wire, means if it is a mild steel workpiece is of mild steel, then the wire is also of MS only. So if you will see the bare wire, over that the flux is mounted. Why we are using this flux? It will generate the shielding gases. Okay, it will generate the shielded gases as it will burn. Why it will generate the shield? Why it's not metal, but when it is generating the shielding gases, what is the need of that? Okay, and if we talks about the tungsten inert gas welding, then we are using the inert gas there, means argon, neon, or helium, or combination of that. We are using that. So why we are using that gas? Okay, so we are using it just to protect the arc from the atmospheric gases, and especially from the oxygen. Why? Because we do not want that there should be a formation of the oxide that will be create the problem for the human being, means that is hazardous, as well as that will create the other effects, means other defects in the workpiece material or the welded region. Okay, so similarly here also we are using the dielectric fluids. Okay, so if we do not use the dielectric fluid, then spark, no doubt the spark will be generated. It should not be uniform, it should not be predictable. That has been already mentioned in the literature part. We need the uniformity, predictability, that's why we are using this dielectric fluid, as well as apart from that reason that it should not form the oxide, that's why we are using the dielectric medium in which everything is happen. Okay, means the sparking occurs. So is the material removal occurs due to the thermal evaporation and the melting. Please keep in mind the mechanism, the wear material removal mechanism in the EDM is thermal evaporation and the melting. Please keep in mind, this is the objective question, has been asked previously in ESC and GATE examination. In ESC many times, okay, and PSUs तो common है सबके लिए. The thermal heating performed in absence of oxygen causes the oxidation on surface and leads to poor surface conductivity of the workpiece, hence dielectric fluid provided and oxygen free machining. Okay, it's clear. Apart from this, there is a following requirement should be there, that it has sufficient and the stable strength to serve an insulation between the tool and the workpiece uh, till the breakdown voltage is reached. Okay, means breakdown होने से पहले because uh, after after that, when there is a breakdown, means till the breakdown, means after the breakdown, means before the breakdown there is a spark is generated. Okay, so we need the uniformity for that, and after that is also dielectric fluid is required, because if there is no dielectric fluid, then whatever the shock wave is generated because of the collapsing of the ionized column, this will be like, otherwise it will burst in air. Okay, so that's why we need that to absorb, means to provide some compressibility to that shock wave. We have to use the dielectric fluid. Okay, it should be deionized rapidly after the spark discharges has taken place. Yesterday I also talked about this one, because rapidly after the discharge has taken place. Okay, if it will not deionize, it will try to create, because this positive and negative ions, it will, if it will not deionize, then ECM process will occur over here. Okay, so please keep in mind, and flush out the particles that is occurring due to the generation of the shock wave. Okay, because that time only the material, molten material, is mixed with the dielectric fluid, and after that only we can bring it out. Okay, so these are the properties or the requirements for the dielectric fluids. Next is for the electrode material. Okay, what are the electrode material and what are the characteristics required for that? It should be less, there should be less tool wear, obviously, because no, as I said, that there is a removal of the material, because spark is generated and it won't care that we have to remove the material from the workpiece only. Spark don't know that which is tool and the which is workpiece. Okay, now here what we can do is, whatever the material that we are using, there should be less tool wear, because from one tool we are producing number of the work pieces. Okay, so please keep in mind that one. Easily workable, so that intricate shape geometries can be formed. What is the meaning? Intricate shape means कॉम्प्लेक्स शेप कह सकते हैं, या फिर मान लीजिए कि इंटरनल अगर किसी शेप्स में आपको ज्योमेट्रीज बनानी है, कॉम्प्लेक्स ज्योमेट्री, सो this tool you are manufacturing, machining over here, so the machining should be easy on that tool. मतलब tool बनाने के लिए भी तो machining चाहिए ना आपको, so that should be easily performed. Okay, and that we are performing using the hardened material. Okay, so that should be easily, we can perform easily that work. Okay, and we can make the shape of whatever the shape that we are using, complex or the intricate shape, we can make it easily. Okay, next is characteristic, that is a good conductor of the electricity, as both should be required, means not only the electrode but the workpiece should be there. High thermal conductivity, because the temperature generation is very high, so we have to keep in mind. High density and high melting point. High melting point is okay. High density, because the obviously generally if the other properties are increases, then definitely that density of the material is also increases. Otherwise, if there is a if it is a less density, then it will not insert inside the dielectric fluid, so it will try to come it out again. Okay, so we want that there should be some gap should be maintained between the workpiece. It should not be like coming on the it will not be treated like floating on the dielectric fluid. Okay, so that we have to keep in mind. Okay, so what are the preferred material? Okay, electrode materials, that is graphite, copper, brass, zinc alloy, steel, and the tungsten, so that we can use. Okay, so this is about the electrode material. So let's move to the modeling of MRR. इसके बाद मैं कुछ टाइम दे दूंगा आपको, so if you have any doubt you can ask me. Okay, now modeling of MRR, as I said, this is the tool. Okay, which is connected to the cathode side, that is negative, and this is the workpiece which is connected to the positive side, that is anode. Okay, now this is the power supply is on, so the current is passes. Okay, current is passes, and the electron and the positive ions are moved here and there in between the gap. Okay, so this spark is generated. Now the spark is generated, and after that I also said that whatever the what kind of shape it will generate, means it will it will make, okay, when there is a deformation. So we are just assuming that it's a semisphere. So what we are assuming over here is, we are taking that if there is a spark is generated, then we are taking this as a small r, that is the radius of this this workpiece surface. Okay, so we are just assuming that volume of this melted zone. Okay, so this is a melted zone, so I'm just writing with Vm, that is the volume of melted zone. Okay, so this is the volume of melted zone. Okay, now this will be equals to how much? This is the semi-sphere. Full sphere का volume क्या होता है? That is 4 by 3 pi r cube. So semi-sphere का कितना हो जाएगा? That is 2 by 3 pi r cube. ठीक है? This is equation number 1. Now, as we are supplying the current, okay, current and the voltage. So what will be the power? The total power will be equals to V into I. Sorry, V into I. Okay. Now, if I want that energy generated between tool and workpiece, that will be equals to power is V into I, and how much time we are supplying this current when the time is when the timing is on. Okay, that time only we are supplying this current. When there is a timing is off, we are not supplying the current. It means for the spark we just consider this T on only. Okay, we will not consider T off, but the total cycle time, that will be considered as a TC, that will be equals to T on plus T off. Okay, so this is okay, so this is Vi into T on. Okay, so this is equation number 2. Fine. Now, how much amount, if we are considering that the 100% of the energy is generated between the workpiece and the tool is directly transferred to the workpiece or the tool, then there is no issue. But we know that whatever the spark is generated, some amount of that is means all the spark is not transferring only the workpiece only, some amount will is transferring on the tool as well. So the energy dissipated to the workpiece, okay, this will be equals to the workpiece. This is, I can okay, that will be, we can represent this one as ES. Okay, so, or EG also you can write, this is EG. Okay, and this will be equals to EW, that is energy dissipated at the workpiece, that will be proportional to the EG. Okay, now we cannot say, it depends that 100% transformation is there or some less is there. Obviously it is less, but we don't know how much is that, so we are just writing that is C. Okay, that's a constant I'm writing on, this is EG. Okay, now so I can place this value EG over here, so this will be equals to, that implies E W will be equals to C into V into I upon T on. Fine. Now, as this energy is dissipated to the workpiece, and whatever the volume is melted, means this molten material is there, this is melted, because whatever the amount of the energy that is dissipated in this area or in this volume. Okay, so this volume, this Vm, melted volume, is directly proportional to what amount of the energy is dissipated in the workpiece. Okay, it obviously it is greater than the 80% or 90%. So this is Vm is equals to, just we are taking K, another constant, that is EW. Okay, now from this equation number 3 we can place this EW value in equation number 4. So this equation 4 will be equals to Vm equals to K into C into V into I into T on. So K and C is nothing but the constant, so I'm just writing with the another constant which is small x. Okay, so this is Vm will be equals to small x into V into I into T on. So this is the volume equation number 5. Okay, now we have to calculate the material removal rate. So the material removal rate will be equals to how much amount of the volume is removed per unit area, per unit time. So how much amount of the volume is removed, that is Vm, and what is the cycle time, that is Tc. Okay, so just write the value over here, that is MRR will be equals to Vm is X into V into I into T on upon Tc. Tc will be equals to T on plus T off. Please keep in mind this formula. Okay, you can write in your synopsis. Okay, so I'm giving you 2 minutes. If you have any doubts, you can ask me. Okay, so shall we move? Fine. So, sir, C can sub constant है. Actually, Swaminanjan, this is C is a constant. It's like जैसे हम लोग efficiency निकालते हैं ना, कि like efficiency क्या होती है कि like input output upon input. ठीक है. So अगर आप इस equation को इस तरह से लिखेंगे like this इस equation को, this is C will be equals to, this will be EW upon EG. Okay, तो आप इसको अगर इस तरह से लिखेंगे तो C will be treated as the efficiency. If is efficiency क्यों कह रहा हूं मैं, because whatever the amount of energy that is dissipated, how this energies came into existence. अगर वहां पे अगर एनर्जी जनरेट नहीं होती तो एनर्जी डिसिपेट भी नहीं होती. ठीक है, तो एनर्जी जनरेशन इज द input and energy dissipated at the workpiece, that is the output. So output upon input is what, that's the efficiency. Okay, तो आप इसको efficiency की टर्म में भी कंसीडर कर सकते हैं. Is it clear? Okay, great. So let's move. Okay, so there are next is the types of the power generators. So these are, there are, I'm just writing over there these names, but we will discuss only this RC type relaxation generator. And इसमें भी सिर्फ मैं analysis उतना ही करूंगा जितना आपका गेट और ईएस के लिए important है. ठीक है, ज्यादा अगर पढ़ना है तो you can prefer your electrical friend, so he will teach you better than me. Okay, so there are 4 types of the power generators. First is RC type, and or we can say it's a relaxation generator as well. We can also say that is a Lazarenko circuit. Okay, yesterday we discussed about that, and we are calling it as a RC type because R belongs to the refers to the resistance and C refers to the capacitance. Okay, so this is the RC type or the relaxation circuit. Next is the rotary impulse type generators, means on behalf of this resistance and the capacitance we can use the rotary impulse. Okay, apart from this rotary impulse we can use the electronic pulses as well. Okay, so that is another term. And hybrid is nothing but the combination of these 3. Okay, so hybrid EDM system. Okay, EDM generator. So we are just discussing this one only, that is RC type. Okay, this one. So this circuit we also discussed yesterday. This is nothing but the Lazarenko circuit as well. Okay, Lazarenko circuit. Okay, so this is the power supply. Okay, this is negative and the positive side. This is DC power supply. This is the resistance. Okay, and this is the capacitance that is represented by the C. We are using another mechanism, means tool and the workpiece assembly over here. If you will prefer any of the books, then you will see that अगर आपको इलेक्ट्रिकल की बुक अगर प्रेफर करेंगे, so here you will find out the diodes or some kind of that mechanism. Okay, but I, for the easy understanding, I use the tool and the workpiece only. So this is the tool and this is the workpiece. In between we are using the dielectric medium. So from that circuit is completed. Now what is happening actually is we are not like we are supplying this current, means we are using this whenever we are using this RC type or the relaxation circuit. Initially we are charging this capacitor. Okay, so for the charging we are supplying the current. Okay, so this is IC. Okay, so we are charging, it means that only the capacitor will charge. So first consideration, first analysis will be based on the charging during the charging zone, or we are basically finding out the charging current during the charging. Okay, second, when the capacitor is 100% charged, at that time we are using, because as I said that we are using the pulse controlled generator. Okay, so this is capacitor is the best source to generating the pulses. So that's why once it is charged, now we are using this capacitor which is completely charged or fully charged. Now we are discharging this one, where we are discharging to supply the current to the workpiece and the tool geometry. Okay, to this or the tool and the workpiece circuit. Okay, now that time we are discharging. तो actually जो अभी हमने voltage और current की diagram पढ़ी है, this one actually the voltage, if you will see the tool and the workpiece voltage, then it will not be actually like this. I will tell you what actually it will be. Okay, so first we are going to analyze that is how what will happen in the charging, during the charging, and what will be the charging current. Second, we will discuss about the discharging, means current during the discharging, and then we will third that we will discuss about the energy dissipated, total energy dissipated during discharging. Okay, so shall we move or we should stop? Tell me, Somaranjan. Stop. Okay, then we will continue tomorrow from this one. Okay, this three will first we will discuss, and because actually I was planning to finish it by today itself, because I added around 6 to 7 numerical problems. So अगर हम ये कल करेंगे, so we have to finish it by tomorrow itself. तो फिर कुछ number of problems जो होंगी फिर वो आपको homework में मिलेंगी, ठीक है? So okay guys, then see you tomorrow. Good night.